Hi, this is Alex Miller, and we're going to learn how to anti-differentiate by substitution. When doing derivatives, we use the chain rule to solve more complex equations, and now we're going to use a similar method for integrals. So far, we've learned basic integrals, and you're going to want to review those and make sure you can do all the basic antiderivatives. You should probably copy down the box on page 332. Looks like this. You need to copy down all of those formulas and make sure you have those memorized, because those are going to be very important when we do this. So, we know so far that a basic trigonometric function like sine of x, the antiderivative of that dx, is negative cosine of x plus c. But what if we wanted to do something like the derivative of sine of x squared dx? What would that equal? Well, I'm going to teach you how to do that today. So since we used the chain rule, we used u to substitute when we first started out, so we're going to use U-Substitution when we do it this way. So to start out, we'll have an equation. I'm going to change it up a little bit, and it'll be sine of x squared sine of x cubed. So we're going to solve for that dx. So first thing we need to do is check and make sure that that's not one of our basic antiderivatives. Right now, since we have a function out front multiplied by another function, it's not one of the basic ones, so we're going to have to use U-substitution. So we can pick a function to substitute u for. So far we have x squared, we have a sine of something, and then we have an x cubed. So I'm going to substitute u for x cubed, so I'm going to set u equal to x cubed. Now I'm going to take u and substitute it back into the equation. So the integral x squared sine of u dx. And we're going to solve for that. Well, now we're closer to anti-deriving, but we can't because we have a variable here that's x squared, and we have a u variable, and it's all dx. So we need to change dx to du to be able to anti-differentiate. So we have u equal to x cubed. So to solve for dx, we need to derive u. So 3x squared equals du dx. And to be able to substitute, we need to solve for dx. So we cross multiply, and we have dx equals du divided by 3x squared. Now from there we can substitute this whole thing in for u. So the integral of x squared sine of u. Now instead of dx, we're going to put in du over 3x squared. Alright, so this is pretty much this whole thing. Now from here we can do some simplification. So this x squared and this x squared cancel, and we're left with a 3 in the denominator. So now we have the integral 1/3 sine of u du. Alright, now we have a basic function that we can anti-derive if we use the rule that says we can take out any constant and move it out front of the integral. So now we have 1/3 the integral of sine u du. Alright, that's a basic one from the sheet that you've already written down, so I hope you know that the integral of that is 1/3, oops, let me move this up, 1/3 negative cosine u plus c. You always remember the plus c. So then if we simplify that, move that up here, and we're going to go negative 1/3 cosine u plus c. Now we can't stop here because we did some substitution earlier, so now we're going to have to change it back. So in the place of u, from up here, we're going to put this back in. So we'll have negative 1/3 cosine of x cubed plus c. Now after we've done that, you can make sure that that's the proper way to do it, and we can derive it. So the first thing we would do is say, okay, we have cosine of x cubed. What's the derivative of that? The derivative of cosine is negative sine, so we have negative 1/3 that we have from the constant. Derivative of cosine is negative sine. keep the x cubed in and then use the chain rule and multiply by the derivative of the inside. So now we have that multiplied by 3x squared. The constant will cancel when you derive. So then we simplify this out. This 3 cancels with this 3. This negative cancels with this negative. And we are left with x squared sine of x cubed. So those two checked. Now to try this technique on your own, go to page 337 and try exercises 1 and 7, and you can check the back of the book to verify your answers. Now that you've practiced U-substitution with an indefinite integral, we're going to try it with a definite integral where there are bounds of integration. So we're going to start with the integral from 0 to 2 of x squared, or x over x squared minus 9 dx. And we're going to try solving this, but we're actually going to get a number because we have bounds of integration here. So we're going to do the same thing as we did before and set x squared minus 9 equal to u, x squared minus 9, and then we are going to substitute u in for the function on the bottom. And then we are going to solve for dx so we can use the integral because the variables have to match. So du dx is the derivative of this, which is 2x. So then we need to solve for dx. So dx equals du over 2x. And then we substitute this in for dx just like before. 0 to 2. So we will have x over u du over 2x. Now we can do some simplification where this x and this x cancel and we're left with a 2 on the bottom and this u on the bottom. So we'll have the integral from 0 to 2 is 1/2 u du. And then we can take the 1/2 in front of the integral, so it's 1/2 from 0 to 2, 1 over u du. Okay, now 1 over u du is one of our basic antiderivatives, which will be 1/2 natural log of u. When you do natural logs, you have to make sure you do absolute value when you antiderive plus c. So we're going to put in our numbers now, but since we changed the u and these bounds were for x, we have to we can do one of two things. We can change u and substitute x back in for it, or we can change the bounds of integration to match the u. So since in the first one we put x back in, I'm going to try it while we change the bounds. So we put 0 in for x and solve for u up here. So x squared is 0, minus 9 is negative 9. So the bounds when we plug these in will be negative 9. Now we put 2 in. 2 squared is 4, minus 9 is negative 5 to negative 5. And then we put the first one in and subtract the second. So we will have 1/2 natural log of absolute value of negative 5 plus c minus 1/2 natural log absolute value of negative 9 plus c. This. So we can factor out a 1/2 absolute value of natural log of 5, what will be just be natural log of 5. This, and then this plus c and this plus c will cancel. We factored out this 1/2, so it'll be minus natural log of 9, since we absolute value this 9. Then our log properties allow us to do this minus this is the same as 1/2 natural log of 5 over 9. and that will be your final answer. You can plug it into the calculator and get an actual decimal answer if you want. The other way we could have done this is if we go back to this part right here where we left it as u. If we wanted to substitute in x again, we could have had the 1/2 natural log of absolute value of x squared minus 9. But then we would have left the bounds of integration at 0 and 2. Okay, so now we would put a 2 in here and get 4 minus 9 would still be negative 5. And then we would minus 0 in, and you would get negative 9, and it would still come out the same, but you would just do another step of putting the x back in. So you can either put the x back in and use the original bounds, or you can change the bounds and leave it as u. So whichever you find easier to do, it still works both the same ways. Or it works the same both ways. Now, after you've watched this and you feel comfortable, go and do exercises 61 and 62 on page 337 or 338. Sorry, and then see how comfortable you feel doing this type of integration.